Hello everyone, myself Shubhangi Kaikar. In this tutorial, I am going to explain the Hamming code. Hamming code it is used for error correction and detection method. So when we are transmitting the information from two networks, it is observed that when we are transmitting the information from network 1 to the network 2, here some type of noise is to be introduced. That is called as an error. So when we are transmitting the binary signal, in this signal the 0 is changed to 1 and 1 is changed to 0. For example, if we are transmitting such type of data as 0101, in this data this 0 is changed to 1. Similarly, if you are transmitting such type of information 010, 011, here also the some bits of this original information are changes. So the error is to be introduced while transmitting the any type of information. So what are the objectives behind this Hamming code? So to study the construction of Hamming code for a 4-bit message for even and odd parity. Second objective is to create a 1-bit error in the Hamming code during a transmission of 7-bit Hamming code. To find a 1-bit error position in 7-bit Hamming code. So simply Hamming code is nothing but a single bit error detection and correction method. As we have discussed, when transmission of digital signal takes place between the two systems, such as in between two computers, the noise can introduce an error in the binary bits. That error means 0 changed to 1 and 1 may be changed to 0, and transmitted data is corrupted due to that type of error. There are many methods to detect and correct the error. Out of that, we are going to study the two methods. So when we are generating the Hamming code, here there is a parity bit is present. So parity is nothing but the simplest technique for detecting the errors is to add an extra bit, which is known as a parity bit. Generally, the MSB of an 8-bit word is used as the parity bit and remaining 7 bits are used as data or message bits. In this, if you seen, the MSB is filled with the help of this parity bit, and remaining positions as D0 to D6, these are the message bits or the data bits. There are two types of the parities are available. One is even parity and second one is the odd parity. Even parity means the number of ones in the given data is even. Such type of parity which is called as a even parity. Odd parity is nothing but number of ones are odd in the given data bits. That is called as a odd parity. If you see in this example, here there are total 3 number of ones are available. So 3 is a odd number. Hence the parity behind this data is odd parity. Now here we have to generate the Hamming code. So when we are generating the Hamming code, we require the message bits or the data bits, and that message or data bits are denoted by notation as M, and one more thing we require the parity bits, and that parity bits are denoted by the notation as P. Here the parity bits are inserted at each 2 raised to n bit, where the n is equal to 0, 1, 2, 3 and so on. So if we put all these values as calculating for P1, you can put the value as 2 raised to 0, that is equal to 1. P2 you get the value as 2 raised to 1, that is value of n is equal to 1. At that time you get the value is 2. So there is a simple mathematical equation to add the parity bits. So equation is 2 raised to p which is greater than or equal to. So what type of procedure you have to follow for generating the Hamming code? Here first take the 4-bit message as M1, M2, M3 and M4. For this 4-bit message, construct a Hamming code for a 4-bit message for even as well as for odd parity manually on either a paper or whatever the media you are using. Make the circuit connection according to the circuit diagram. Set the input 4-bit message by using the switches provided on the circuit board, and according to that observe the 7-bit Hamming code. Note down the 7-bit Hamming code in the tabular format. Afterwards, we have to assume a single bit error in the 7-bit Hamming code by using the switches provided on the circuit board, and we have to observe the error position in the Hamming code. So here there is one limitation you getting from this code, as only a single bit error detector method is used. It cannot find the more than 1 bit of error with respect to this Hamming. Here we have to check the occurrences of ones for P1, P2 and P3 and P4. So occurrences of 1 is nothing but whether the first one is coming. So if you observe this, the first column, this is for the P1 position. Second column is for P2 positions. Third column is for P3 position, and fourth column is for the P4 positions. So if you observe this P1, here the first one is coming for the position number 1, then second one is coming from the position number 3, third one is coming for the fifth number position. Likewise, we can write the positions for P1. Same way, we are writing the positions for P2 as 2, 3, 6 and 7. P3, first one is coming for the fourth position, then fifth, sixth and 7. Likewise, we are writing the position numbers for all these parity bits. Here we require only the 3 parity bits. So here we are writing the positions as 1, 2 and 4 for writing the parity bit positions. So P1 at the first position. So in this way we are writing here the Hamming code for a 4-bit data. So let's consider here we are taken the 4-bit message as 1011. So now here we are putting. So same example here with the help of different steps I have written. Please see this example for your more understanding. Find out this for Hamming code for this 4-bit data. Similarly, in this second example, whatever the data is received by the receiver, that is shown, and according to that here the error detector output is to be octet. So thank you very much for listening this